I've always liked drawing, like a lot. And my drawing process always looks a little something like this. I get out a pencil and a piece of paper and I start to draft my ideas. And I got thinking, what really is a pencil? Like, it's a thing that I draw with all the time, but I'm not really sure what it really is. But I can tell you what it's not. It is not lead. And just a side note, the reason why it's always called pencil lead is because when they first discovered it,
they thought it was a form of lead, but in reality it wasn't, and there is no lead in graphite, so all that was false.
Pushing that aside, what is the lore behind graphite exactly? Well, to assess, let's first take a look at this one element. Initially, it doesn't seem like graphite and diamond would be anything related, but guess what? Would you freak out if I were to tell you they were siblings? Well, not exactly. They are both allotropes of carbon, which means their chemical formula both consists of pure carbon, but the way they are bonded together is what makes them different in their elemental properties. For example, the carbon bonds in a diamond form a tetrahedral shape, which means that they have 4 bonds and they have bond angles of 109.5 degrees each. Essentially, that just means that it makes the diamonds a very strong and durable material. But we already knew that. What about graphite? Carbon atoms in graphite are bonded to 3 other carbon atoms, and they're connected via single covalent bonds, which are in fact stronger than in diamond. And they're shaped in a hexagon pattern. And this is what makes up a single layer of graphite, and they're called graphene. Now, you may have noticed that I only mentioned 3 bonds in graphite. Well, what happens to the 4th electron? So the 4th one is kind of left as a spare, and it's pretty much free to just go wherever around the whole sheet. Well, not exactly. It becomes delocalized, and they are free to move anywhere within the sheet, so within the layer of graphene. This actually provides a great example of van der Waals dispersion forces, because this delocalized electron that's just freely moving around can actually cause temporary dipoles to form, which will cause dipoles in other sheets that are above it or below it. Essentially, what all this means is that graphite will have a very soft feel, and it can be an ideal solution to use as a writing utensil, which is why it's in pencil, and also it can be used as a dry lubricant for things like locks or even things like railway track joints. And although this is technically out of scope for this video, graphite in and of itself isn't that strong. However, the individual layers, graphene as you may recall, they themselves are very strong, and they actually are showing great promise in the industry of nanotechnology because they're so thin, yet they're very immensely dense, which just means that it's going to be very hard to penetrate through these guys. So basically, it'll be great candidates for producing something that's light, flexible, but something that needs to be very powerful. So yeah, I guess graphite can be a writing utensil, or it can be the product of the future.